Hi, and welcome to another interesting video. My name is Success Promise by name, and I'm an electronic enthusiast which actually posts electronic content. Into this video, we're going to be interfacing with this lighter right here. Yeah, this is a normal lighter which a normal lighter which is used in kitchens and part of the kitchen utensil. So in this video, I'm going to be talking about what is this used for and how does it actually create this. Yeah, I know you will be very excited to know about how this actually works. So do want to stay to the ending of this video to get great insight and educative knowledge. Let's go. Now, talking about this lighter, there is an important thing which I want to really talk about this lighter is that how does it actually generate this spark? I don't know if you can see it right there. You can see the little spark is actually generated. So how does it actually generate that spark? That is the main idea which I'm actually creating this video for, and that is what we're going to be learning today. So I'm not going to be tearing up this lighter actually, because yeah, I'm not going to be opening this lighter up. But I'm going to give you a scheme diagram of how the lighter look inside, and we're going to discuss about how it works. So let's go to that first of all. Okay, looking at the setup, I actually shared the sections of how the circuitry is actually connected. I eventually open up the lighter because I said in the intro of this video that I'm not going to be opening up the lighter. But yes, we need to open up the lighter to know how it works and how it's connected. I have opened up the lighter and I'm going to show you guys how it looks in the lighter. But firstly, let me explain how it's connected inside. Now, firstly, we have the power supply, which is usual for every circuit. A circuit must have a power supply which is works with. And secondly, that power supply, I'm going to tell you the voltage, the currents, and everything when in the next clip, which I'm going to be opening up the lighter. But yes, we have the power supply, which is the first thing. I'm going to call that the section A. Now that power supply feeds into the MOSFET. We have a MOSFET inside of this lighter, and the procedure actually with the way the lighter is actually connected is that this procedure of the lighter actually works on self-oscillating. Yeah, it actually do not have an external IC or any microchip which is actually built on the board, or which is actually built inside the lighter, but it has the MOSFET and a transformer. Now with the help of the transformer feedback, which is actually fed into the MOSFET, it helps the MOSFET to self-oscillate into a particular tuned frequency which is actually set by the manufacturer, and the transformer is actually there to step up that voltage, that little voltage which generates the spark. As you can see right here, the spark is actually the plasma which you actually see at the top of the lighter right there, as you can see below. And yes, this circuit actually works on self-oscillating. It doesn't have an external chip. As I said earlier, it self-oscillates with the help of the transformer feedback. If you really don't understand and want to get the main full breakdown on how the MOSFET actually self-oscillates with the transformer, I actually made a video a couple of years ago, 2 to 3 years ago. I made a video kind of old, but yes, I explained basically how the transformer actually works with the MOSFET to self-oscillate and stuff like that. I made a high voltage generator 2 years back, and in that video I actually explained how it actually works. You can go check it out right there to get the main solid idea. But yes, I'm just gonna make a quick wrap up on how it works. As I said earlier, it has the power supply, which is the taking charge of the power in the circuit up. Secondly, it powers to the MOSFET to actually do the oscillating, switching, turning on and off to create the frequency tuned by the manufacturer. That frequency actually goes to the transformer, actually the step up transformer, which actually steps the voltage up, and we get our sparks plasma. And because of the high voltage which is actually generated from the output side of the transformer, it ionize with the air and actually creates a spark, and that's why we see a little plasma which is actually generated. As I said earlier, if you want to get the full breakdown, I actually made a full video which actually explained how the transistor actually works with the transformer and feedback loop and stuff like that. But all what you just have to know is that there's a power supply which actually powers the MOSFET. The MOSFET turn on and off, create a frequency, goes to the transformer step up the voltage, boom, we have a plasma at the output. I'm really going to open up the circuitry so that you're going to see how it works and stuff like that, and also the components which are actually imputed into the module. And also, I didn't mention we also have another box right here, which I'm going to be calling the charging IC. We also have another charging IC, which is responsible for charging up the battery and also showing the battery level. Yeah, this charge IC is responsible for charging up the battery and also showing the level. You can see some kind of 4 LEDs right there. Those 4 LEDs actually shows the battery level, and for the user to know when the battery is down and stuff like that, and when you need to charge it. So this charge IC is responsible for charging the battery right there, and the battery does the rest of the job. So yeah, I'm gonna open it up for you guys and you're going to see it. Or real quick, if you really don't understand what I'm actually saying, just let me know in the comment section. Anyway, you're confused, I'm gonna go straight to it and I'm gonna explain it for you. Let's go to the opening.
Okay, now as I said in the intro of this video, I'm not actually going to be opening up the lighter, but it comes to a point that I really need to open up the lighter so that we're going to get more insight and also how everything works. Now I hope you really understand what I actually said a few minutes later when I talked about how the circuit actually works. Now let's open up the lighter and let's see what is actually inside. Okay, now looking at the lighter right here, we have 2 screws. Yeah, we have a screw at the top and we also have a screw at the bottom, and we're gonna get rid of it in 3, 2, 1, boom. Okay, we are inside the lighter and it looks pretty small. Like, I was not expecting this. I was expecting something bigger, but anyways, this is the lighter. And also, I was not expecting a lipo battery. I was expecting a cylindrical battery. That is why it really runs down really fast. I was expecting for the manufacturer to put a cylindrical battery. I was not expecting a lipolymer battery, but maybe just to make things more small and tiny, they just decided to use a lipolymer battery. But anyways, all good. Now looking at the lipolymer battery, we have 220 milliampere. Wow, this is really small. Anyways, 3.7 volt as usual and 4.2 volt at its maximum voltage. And looking at the component which is actually on the circuit board, you can see the charging IC right there. This is definitely the charging IC. They didn't write anything on it. I was thinking it's the IC responsible for PWM frequency generation, but I think no, it is not responsible for that. This is definitely the charging IC and also the battery level indicator IC. It's responsible for charging the IC and also responsible for showing the battery level so that you know when the battery runs down and you need to charge it. Now looking up right here, we can see a MOSFET. Yeah, and I guess this is the N-channel MOSFET. When I checked on the web, there's the N-channel MOSFET. We're going to go to the data sheet in a few minutes. Okay, now this MOSFET, I guess it's responsible for generating the high frequency. I can't see any other ICs or stuff like that for generating any frequency or PWM signal, so I guess this circuit is actually self-oscillating. Yeah, I'm really sure they actually use the self-oscillating pattern to create this high plasma, because if you watch my video which I actually created about 2 to 3 years ago, you're creating a high voltage generator using a flyback transformer, I actually follow the procedure of self-oscillation. Yeah, you just need a MOSFET, a transistor, sorry, you just need a MOSFET, a transformer, and you're done. You can create high voltage. So I guess that's the procedure which they use. And looking at the MOSFET name, CLE30N10, I guess this is the N-channel MOSFET. We're going to look to that in a real quick. Okay, right here we also have a few capacitors and resistors normally, which is going to support the circuit. And we also have the bulb right there, which actually shows the battery level. And also we have the transformer. Actually, this is actually the step-up transformer, which actually step up the low voltage to the high voltage plasma, which we actually see at the top right there. Well, this is a really cool circuit and really cool design. I really appreciate it. The battery, the charging IC, the MOSFET, and also the procedures. I hope you really understand how it works. If you don't know how it works, you can go check out my video which I made with high voltage generation using flyback transformer and a MOSFET. I explain more on how it works, but really cool circuit and really cool design. and very portable and really nice. Okay, let's test it as it's naked, and let's see if it actually still works.
We want to test this naked, if not in the case, but let's see if you get shock. Let's test it out. I know it's risky, but let's just see how it works. Turn it on first, then I'm gonna bring the camera closer. Alrighty, okay, it's turned on, and this is where the spark should be coming out from. Now it's turned off. Let's turn it on again. So let's press the switch and see. Alrighty, you still get the spark. Nice. Okay, nice. I can hear some plasma smells. Plasma. Alrighty, ladies and gentlemen, it worked.
Alright, here's a snapshot of the data sheet of the MOSFET. If you just want to screenshot it or stuff like that. The MOSFET is a 30 amps MOSFET and 100 volts. So okay, it works perfectly and nice. I hope you really enjoyed the video. If you do enjoy this video, do well to give me a like, subscribe to my channel so that you get more of this content, and also check out my Patreon, which I'm going to be posting the first link in the description. You got to lead you to my Patreon. You can join for free. And let's quickly close up this bad boy and let's pray it actually still works.
Okay, I guess you have got a quick wrap up on how the lighter is actually built and actually how it generates the electricity from the output side, which is the high voltage side right here. And also you get the knowledge that there's actually a lithium battery inside here, maybe to 4.2 volt type of battery, and 3.7 volt specifically, and maybe there's also a battery charger inside this lighter which actually charges the battery. And you can see the battery indicator right here, which actually shows the percentage of the battery according to the way you charge it and the level of the battery, stuff like that. So yes, I hope you get something new and you get the full brain tutorial. If you really have any questions or you're kind of missing a kind of a point, you don't have to know it's the one I'm saying, just let me know in the comment section below and I'll talk to it straight ahead. So yes, it creates 1,000 volt right here. And the last question, which is my least, is does it hot? Yes, we're going to put to test and let's see if it's actually hot. You know, it generates a kind of sparks right here. Sparks are really dangerous. I know it's kind of it does not hot, but yes, it do hot, as you can see right here. Yeah, it does hot. So let's put our hand and see how it goes. In 3, 2, 1.
It was at this moment that he knew. He fucked up.
Ow! Ah! My God, it's really hot. Don't try this at all. My God, my skin is swollen. It's really painful. I know these kind of videos are really educative and also to let you know that these gadgets are dangerous. But yes, I successfully got my fingers burnt up and I really appreciate that. So you do also subscribe for more hotty videos like this. I'll see you in the next one, chat. Peace out.